You know that glowing rectangle in your pocket? The one you use to, I don't know, scroll through cat videos and argue with strangers on the internet? Well, it turns out it's secretly a highly sensitive, life-saving scientific instrument.
Welcome to today's Explainer. We're looking at a literal high-stakes race. It's a sprint between the unforgiving, raw physics of a rupturing fault line and the invisible, lightning-fast digital data right there in your pocket. The prize for winning this race? Precious seconds. Seconds that absolutely can mean the difference between getting to safety or being caught completely off guard by a massive earthquake.
So the unsung hero of this whole story is the accelerometer. You know that tiny little sensor that magically flips your screen to landscape mode when you turn it sideways? Yeah, that one. It turns out these sensors are so incredibly sensitive that they don't just know when you're playing a mobile racing game. They can actually detect the specific telltale vibrations of the Earth literally cracking open beneath you.
Section 1. Your pocket seismometer.
Now, a single phone detecting a vibration, that's a neat trick. But networking millions of them together, that creates the largest earthquake detection system in human history. Patrick Robertson, a software engineer on Google's safety team, put it perfectly. He said, "We use the phones that are sitting and charging, idle and stationary. We turn them into mini seismometers. So while you're fast asleep, your plugged-in phone is literally standing guard."
Section 2. P waves and S waves. To understand how this system actually protects you, we kind of have to look at the physics of an earthquake. When a quake happens, it sends out two main types of waves. First up, we have the P waves, or primary waves. I like to think of them as the Scout. They are fast, traveling about 3.7 miles every single second, but they're relatively weak. You honestly might not even feel them. But then, lagging just slightly behind, comes the S wave, the secondary wave. Moving at a slower 2.5 miles per second, this guy is the wrecking ball. It violently shears the ground up and down, knocks over buildings, and, well, completely ruins your day. Imagine this. 10 seconds after a hypothetical rupture on the San Andreas Fault, waves are radiating out from the epicenter like ripples in a pond. The P waves, our scouts, are way out in front, harmlessly washing over thousands of smartphones. But the destructive S wave, it's still localized near the rupture. And that geographic gap between the two, that right there is our window of opportunity.
Section 3. Racing the speed of light. Okay, here is the algorithm happening in real time. Step 1. Your stationary phone detects that fast, weak P wave. Step 2, it instantly pings a central server with a coarse, privacy-preserving location. Step 3, the server aggregates signals from hundreds of other phones in that exact same area. If enough phones report that they just felt a P wave, the server calculates the epicenter and the magnitude and blasts alerts to everyone in the surrounding regions. Because cellular data travels at the speed of light, this entire process happens in just a fraction of a second.
50 seconds in, the S wave is spreading, but the digital alert has already reached cities miles away. The cellular data easily outran the physical earthquake. It turns out the speed of light beats the speed of rock every single time.
Section 4. The crowd-sourced network.
You know, relying entirely on traditional scientific equipment definitely has its limits. Here in the US, particularly on the West Coast, we have the incredible ShakeAlert system. It uses over 1,300 fixed, highly precise USGS seismometers. It's totally the gold standard. But deploying expensive scientific hardware globally? That is tough. And that's exactly where the Android Earthquake Alert System comes in. By crowdsourcing millions of everyday phones, this system is now active in over 97 countries. If a magnitude 4.5 or greater quake is detected, boom, the system springs into action.
And when an alert hits, it doesn't just yell earthquake, it literally counts down the exact seconds you have remaining until the shaking hits your specific location. Imagine getting a loud ping, looking at your screen and seeing 28 seconds until strong shaking expected. I mean, that is the ultimate heads up.
Section 5. The blind zone problem.
Now, the laws of physics are absolute, and sometimes you just can't win the race. This creates a phenomenon scientists call the blind zone. Basically, if you are located right on top of the epicenter when the fault ruptures, the P wave and the destructive S wave arrive almost simultaneously. The server simply doesn't have the physical time to process the data and beam an alert back to you before the ground is already shaking violently. The system is incredibly fast, for sure, but hey, they can't time travel.
Because of this blind zone, developers are actually working on complementary, localized systems. Apps like the MK Earthquake Monitor don't rely on the cloud at all. Instead, they run dual filters locally on your single device to detect P waves directly. Now, while single-device apps don't have the multi-station verification to prevent false alarms like the network systems do, they serve as a crucial offline layer of defense, for when the internet is down or you're just too close to ground zero for network alerts to reach you in time.
Section 6. Drop, cover, hold on.
Okay, so you've won the race and the alert reaches you. What next? Well, your phone will deliver one of two warnings based on the expected intensity of the shaking at your location. First is the Be Aware alert. This is for light shaking, usually a 3 or 4 on the modified Mercalli intensity scale. It's just a heads up. But if the system expects moderate to extreme shaking, a 5 or above, you get the Take Action alert. This literally takes over your entire screen and bypasses your Do Not Disturb settings to blast a really loud warning sound.
When you see that Take Action alert, the protocol is simple and proven. Drop to the ground, take cover under a sturdy desk or table, and hold on. Seriously, do not try to run outside while the ground is heaving. And the crazy thing, it's not just humans taking action. These early warning data feeds are plugged directly into our infrastructure. In those few seconds, computers can automatically slow down high-speed trains to prevent derailments, close massive water and gas valves to prevent fires, and even automatically open firehouse doors so the trucks don't get jammed inside when the building shifts. It's an incredibly choreographed dance of data and physics.
We've literally taken everyday consumer electronics and linked them together to outrun seismic waves. It begs a fascinating question to end this explainer on. If the device in your pocket is already part of a global seismometer network saving lives, what other massive scientific challenges could we solve by networking the technology we carry every single day?